Now let's take a quick look at the designs of correlational studies. It's not complicated at all. In quasi-experiments, we had only two letters, O and X was intervention. In correlational studies, we don't have any intervention. We only measure things. That's why these designs for correlational studies can be written down using just one letter, O. So it will be like O, 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 or O, or O, O, etc. Let's see the difference between those cross-sectional, longitudinal, and mixed correlational designs. What are cross-sectional designs? It's a situation when you measure a bunch of variables at one point in time. That's why they're called cross-sectional. Just at one point in time, you make a section and you measure a bunch of variables. You can measure those variables in one group of individuals, and you might be interested in the associations of those variables. Or you can measure those variables in several groups of individuals, and you might be interested in comparing those groups. And those groups can be independent, or they can be hierarchically structured. Like, for example, you have children grouped in classes and classes grouped into schools, and there are some variables at the level of school and at the level of class, like the number of children or attitudes of school headmaster. And if you have this bunch of data, you will need a multi-level model. Luckily for us, it's rarely that we have this kind of data, so normally we just work with data from a single group of individuals. How does it work? Let's take a look at this simple example of a study using a single group. It's our study with Ilona Bonneville and Adrian Renton, where we used a sample of residents of a poor area of London, 800 individuals. How did this study come about? Basically, it was an ad hoc study. I will explain a little bit because this is not the way you are supposed to conduct good research studies. So it all started with colleagues from the University of East London coming to us and saying, look, guys, you are positive psychologists, and we have some really cool data that might be interesting for you. We have conducted a sociological survey. We paid a lot of money from a grant to sociologists who went around this poor area of London, and they asked a bunch of questions to residents living in each household. And among those questions, there were some questions on well-being, how happy you are, and some questions about their lifestyle, their physical activity, and some other things. So colleagues said, why don't you explore this data set, and maybe there is something interesting that you will want to publish. And we explored this data, and we found this association between happiness and having internet at home. So we thought, does having internet make people happier? And obviously, you start thinking about alternative explanations straight away. Why do people who have internet are also happier? Maybe because they earn more money, or maybe because they are more educated, or maybe because they're younger, or maybe there is some other reason. So there are a whole bunch of possible alternative explanations that you can propose. Maybe this correlation is completely spurious. Luckily for us, in this data set, we had also a bunch of socio-demographic data. So we could control for education, income, for gender, for country of origin, for age, etc. And we found that even after controlling for all of these variables, there still was a statistically significant association between having internet at home and the level of happiness. So this correlation was 0.13 after controlling for those alternative explanations. And it was only income that basically predicted strongly happiness and internet access. So we said, okay, maybe we can try publishing these findings. But of course, to make these findings publishable, we had to think of potential causal pathways. Why do people with internet live happier lives. And we thought about possible explanations. Maybe people who have internet at home maintain closer ties with their relatives and friends. Or maybe people who have internet at home are more likely to learn about interesting activities. And maybe they are more likely to go out and participate and attend theater shows or some other community activities. So we had those hypotheses, and luckily for us, in this data set, there were also variables quantifying the extent to which people go out, the extent of social ties and social support. So we created this structural equation model where we had questions: how many people you have who can help you with shopping, lend you money when you're in need, or support you in crisis. And those were 3 questions that we used as measures of social support. And we also had 5 questions that we used as measures of social ties. How often do you phone relatives, or write to relatives, or meet friends, or phone to friends, etc. And we found that people who have internet access at home, they are more likely to have better social support, and they are more likely to maintain stronger social ties. And those 2 variables predicted their happiness. So maybe those 2 mediating variables could explain the reason why people with internet are happier. But of course, there is no guarantee that there is a causal link, because there might be a 3rd variable behind those associations. Some unmeasured variables that might be very important, but we don't really know that it's important. So we managed to make this data publishable. But unfortunately, when we tried to publish it in a good journal, it was not very publishable, because people said, okay, guys, but your data is only correlational. Your measure of internet access is not perfect. It's basically a question, do you have internet or not? Nowadays, there are many other studies, reviewers said, there are many other studies showing that the effects of internet on happiness actually depend on how people use the internet. What kind of activities do they do online? And we said, that's bad news. So we ended up just publishing this paper in a very bad journal, because we didn't really want to throw it out in the dustbin. But of course, this kind of approach, if you take some data and you try to find something interesting in it, is a recipe for a bad study. So don't do it. Think about your hypothesis, think about your measures before you collect your data. But it's just an example of a cross-sectional study where you have a bunch of variables and you try statistically to control for alternative explanations if you have those 3rd variables measured. And you might want to test some more complicated model like this path or structural equation model of mediation, when we have a hypothesis that variable x leads to some kind of variable m, which leads to some kind of variable y. But of course, even if this model has some underlying causal logic, there is no way you can prove this causality. You can only say, okay, this model fits my data, but maybe there are other models that are better. Maybe the other models are more correct, but we don't have the data, we don't have an idea of those models. That's why cross-sectional correlational data is considered the weakest type of evidence that we can get. There is no guarantee that these associations are not spurious. That's why reviewers don't like cross-sectional correlational data. So if you really want to publish a good paper, it's better to put together several studies. If one of them is cross-sectional, correlational, maybe another one should be longitudinal, or a 3rd one should be experimental. And if you show that you have the same effect in all those 3 studies, that would be much stronger as evidence. A slightly more complicated type of correlational studies are longitudinal studies. It's a situation when we monitor individuals across time. So instead of measuring everything at one point in time, we conduct several measurements at different points. maybe several days or several weeks or several minutes apart. For example, diary studies are also longitudinal studies where people complete the same questionnaire every day or maybe every hour even. Or sometimes they complete this questionnaire every year. So the time interval in longitudinal studies can be completely different. And there are some really well-known longitudinal studies in some countries where people have been monitored for decades. Classical longitudinal studies started by Louis Terman in 1930s. They are still going on, even though the researchers who started the original studies are already long dead, and maybe even the second generation of researchers are retired emeritus professors. Still, the participants are alive, and some researchers come to them every year or every couple of years and give them some questionnaires and conduct some interviews and collect this very important data. For as long as those participants, some of them are still alive, it makes sense to go on with this longitudinal study. Obviously, it's a very ambitious project and you need a lot of funding, and you need a way to guarantee that this funding will be available for some 50 years or longer. Obviously, it's not really possible to conduct a longitudinal study at this time scale in many countries, in many research institutions. And in the context of your master's thesis, obviously you're not going to be writing it for 50 years. But you can still consider a longitudinal study because the space between measurements can be some weeks apart. As an example of this longitudinal study in a single group, I will show you data from a paper by Sonia Lubomirsky, Ken Sheldon, and Ashkate, where they tested one of the parts of the theory, sustainable happiness model, or hedonic adaptation prevention model, as they called it at another point in time. And the question was, what helps people to make changes in their life that result in sustainable happiness? And in this study, they had 669 students, basically undergraduates of the University of Missouri, who were measured 4 times during the semester at 6-week intervals. So first they were measured in September, then at the middle of October, then at the end of November, and finally in January. And at each measurement wave, they were asked some questions about their well-being at time 1 in September, and then at time 2 in October, researchers also included measures of positive changes in activities and positive changes in circumstances. Basically, students were asked to rate all of the things that have changed to them after the start of this semester. And this was their first semester at the university, so some of them have moved to a new apartment, some of them have established a new relationship, and so on. So students basically made lists of things that have changed, and then researchers have coded whether it was a change in circumstances, for example, I got a new car, or I got a new apartment, or a change in activities. For example, I started learning a new language, or I established a new relationship, or I started a new hobby. And for each type of change, they had a quantitative measure, which was the number of changes. And then well-being was measured at time 3 and time 4 at the end of November and in January. And they tested this regression model, where they tested whether the change in positive activities and positive changes in circumstances would predict increased well-being. And they found that the change in well-being at the end of November relative to September, so time 3 relative to time 1, was predicted by both types of changes. So those who got a new car or a new apartment were happier, and the difference was comparable to those who started a new hobby or a new relationship. But when they tried to predict time 4 as a dependent variable, controlling for well-being scores in September, they found that it was only positive activity change that predicted increased well-being at time 4 in January. But positive circumstantial change, its effect was short-lived. And this way they used this study as one of the studies that supported their sustainable happiness model. And they made this argument that if you want to be happy, it's better to think about changing something in your activities or hobbies or relationships rather than just getting new things, buying new clothes or new cars or new apartments, etc. What is the recipe for a successful longitudinal study? If you remember when we were discussing experimental designs and quasi-experiments, we discussed that when you have an experiment, it's better to have pretest. Even though if you randomize your individuals, you might get by without a pretest. But if you do a quasi-experiment, if your groups are non-equivalent, you absolutely must have a pretest. The same thing in longitudinal studies. You must have a measure of your dependent variable at the beginning and throughout your study. So you might have some variables that you want to treat as predictors and some variables that you want to treat as mediators. But if you want to make an argument about change, you need to have a measure of your dependent variable throughout so that you can control for pre-existing differences in your dependent variable. So because they had this measure of well-being in September, they could control for well-being in September. They could take out the variance, pre-existing variance, pre-existing differences in well-being between individuals due to extroversion, due to genetic background, due to family circumstances, etc. And then they could see that changes during the semester could predict additional variance, additional individual differences in well-being after controlling for pre-existing differences that existed before. If they did not have this time 1 well-being score, they would not be able to make this argument, because the first reviewer would say, okay, your positive activity change predicts well-being later on, but maybe there is a third variable. Maybe pre-existing differences in well-being explain why people engage in more positive activities and why they, in the end, are happier, because they were happier at the beginning. So you need to have this time 1 measure of your dependent variable, even if no effect has taken place yet. And if you have several variables in your causal sequence, like predictors, mediators, dependent variables, it's best to have them all at all occasions. Of course, maybe you don't need to measure your predictors at the end, but at least your dependent variable and each variable that receives some effect, for example, the mediator, you need to have it at all occasions. So that's the longitudinal design. And of course, there are some situations when you can choose between a cross-sectional design or a longitudinal design. For example, if you are interested in the association of some variable with age, for example, well-being and age, you can, or IQ and age, you can use two different approaches. You can say, okay, I will go to individuals at different ages, administer an IQ test, and I will compare the scores. And people who use this approach, they typically find that IQ declines with age. And this decline is very pronounced. But there is an alternative explanation: cohort differences. If you measure today people who are 10, 20, 30, 40, 50, 60, 70, 80, and 90, those groups of people will not be completely comparable. First of all, there will be some attrition, obviously, but most importantly, those individuals grew up in different situations. They were born at different years, they received different school education practices, and maybe they are to a different extent familiar with tests. So all of this contributes to cohort differences that you see. And these differences between cohorts, when we say cohort, we mean people born at the same time. Those cohorts may actually exaggerate the true differences in IQ associated with age. Another alternative approach that you can use is longitudinal design, when you say, okay, instead of comparing people at different ages, I will just take one group of individuals and I will monitor them for 60 or 70 years. But obviously, in practice, this is often not very plausible. It's too complicated. It takes too much time. And more importantly, there is also an issue of repeated testing effects. People who participate in longitudinal studies become professional subjects. They are so familiar with tests that this very familiarity can affect their results. So if you want to try to overcome both problems, you need to find a way to combine cross-sectional approach and longitudinal approach. And this is called sequential design. You take several cohorts, you take several groups of people of different ages, and you follow them for some time. An example of such sequential design, which comes from education, is shown on this graph. It comes from a textbook by Park and Clark Stewart. And here, the study began in the year 2000, and then they performed a longitudinal measurement with each group of children at 2-year intervals in 2002, 2004, and 2006. So in 2000, they began with 3 cohorts, children in grade 2, grade 4, and grade 6. In 2002, they added another group of children in the 2nd grade who just came to school. And they continued following the previous 3 cohorts, which were now 2 years older. And then in the year 2004 and 2006, they did the same thing. They continued to add new younger group, and they continued to monitor all the previous cohorts. As a result, this study took only 6 years to conduct, and as a result, this data allows to perform both longitudinal comparisons within each cohort, so you can compare and replicate your findings, and you can also perform cohort comparisons and check whether children at the 2nd grade born at different years or at the 4th grade born in different years, whether they are similar or different from each other. And you can apply a more complicated statistical model to separate those effects of cohort and the effects of time. And you can do the same thing with large-scale social surveys. If you have randomized random samples from the same population gathered using the same set of measures at different years, you can apply a complex statistical model to separate the effects of cohort and the effects of time. And you can get a clearer view of age differences and social changes. So those were just some designs for correlational studies.